Let's say that initially you've got two memory locations, A and B, and both these memory locations have been initialized to 0. And let's say that there are two processes executing on two different processors, P1 and P2. And so A and B, C and D, they're all shared memory locations. And let's say that process P1 is executing this piece of code. It's assigning A+1 to A, B+1 to B. And there's another process P2 that is using the values B and A and assigning them to variables D and C. Now, one thing that you have to recognize is that the processor P1 and processor P2 are working completely independently, right? They are completely independent of each other. It is just that these memory locations, A, B, C, and D, are all shared memory locations. But we have no way of knowing the relative ordering of all of these instructions that we are seeing here. When you think about a uniprocessor program, there is an expectation that instructions are textually, the way they are ordered is the order in which the processor is executing. But what we are looking at is instructions that are happening on different processors. There's a set of instructions here, set of instructions here, all manipulating the same shared memory. So the question to you is, what possible values do you expect to see for D and C? Do you expect that when, let's say that, process P1 completes, process P2 completes, we don't know what order they executed, both have completed execution. At the end of that, would you expect to see C and D to be equal to 0, C and D to be both equal to 1, C to be equal to 1 and D to be equal to 0, C to be equal to 0 and D to be equal to 1? Okay, basically I've given you all the permutation combinations of the 4 possibilities for the values that C and D can assume, given this set of instructions that is happening partially on P1, partially on P2.